The moon might be hiding trillions of dollars worth of materials beneath that dusty surface, and NASA is about to get a piece of it soon. Their new lunar drilling tech just passed its first big test, and it could open up an entirely new frontier: space mining. This isn't just a scientific milestone. This could change the US economy forever, and maybe even reshape life on Earth. That's because they found something rare in lunar soil, something that could become essential for us in the future: helium-3. Okay, so you know helium, right? It's the gas that makes birthday balloons float. Helium-3 is not that. It's a special isotope of helium, which basically means it has the same number of protons, 2 by the way, but a different number of neutrons. That's chemistry speak for it's rare, like super rare. Here comes the sad part. Earth had helium-3 once, a lot of it actually. But during our planet's formation, a lot of it escaped into space. Turns out, it's super light, so it didn't stick around. But we can still find it here and there, mostly inside our planet. I mean, there's some of it literally trapped underground. Or even a lot, as some recent studies might suggest. But still, the problem is that extracting helium-3 is expensive, limited, and seriously difficult. So difficult, in fact, that getting it from the moon suddenly sounds like a piece of cake. To really understand why extracting helium-3 in space might be easier, we need to quickly compare Earth and the moon. So here's the sun, right? This huge ball of fire in the sky constantly shoots out tons of helium-3. When this helium-3 reaches Earth, our planet's magnetic field acts like a giant invisible shield, basically saying, "Nope, not here," and it deflects most of it away. But the moon doesn't have a friendly protective magnetic field like Earth does. So when helium-3 reaches the moon, it hits the surface directly and gets trapped in the lunar regolith. I'm talking about that loose layer of dust, soil, and rocky debris covering the moon. And there might be tons of it, literally. Some estimates put it somewhere between 1 and 3 million tons of helium-3. The best part is that almost all of it is probably sitting right in the top layer of lunar soil. So instead of heavy-duty drilling, it could be as easy as just scooping up some moon dust. That's why a lot of people think getting helium-3 from our natural satellite could actually be way easier, or maybe even cheaper, than digging deep underground here on Earth. Now, you're probably thinking, why go through all that trouble? I mean, if it doesn't work for birthday balloons, what's the big deal with helium-3? Well, for starters, it's already being used in advanced medical tech, like magnetic resonance imaging and X-ray. But here's the real game changer. Helium-3 could actually end our dependence on fossil fuels for good. This rare isotope could be used for advanced nuclear fusion reactors here on Earth. In other words, it could give us nuclear energy that's not just super efficient, but a whole lot safer too. See, most nuclear power plants today run on a process called fission. They use uranium-235, and when those atoms split, you get a ton of energy. But you also get something else: radioactive waste. And yeah, it's just as dangerous as it sounds. But helium-3 is different. It could power future reactors with a process called fusion. If you mix helium-3 with a type of hydrogen called deuterium, you get a lot of energy, but without the dangerous waste. It could be cost-efficient too. Let's say a single space shuttle cargo bay could carry about 25 tons of helium-3. That would be enough to power the entire United States for a year. And scientists believe there's enough helium-3 on the moon to power the whole world for 10,000 years. These are only estimates for now, but the future potential is so exciting that the demand for helium-3 is already skyrocketing, and so is its value. In 2024, some experts say that the helium-3 market was worth about $670 million. This year, it's expected to hit around $730 million. And 10 years from now, experts believe it could reach nearly $1.6 billion. Sorry for all the numbers, I just wanted to show you why mining the moon matters. It might actually save us from a future energy crisis by giving us almost endless, clean nuclear power. Everything sounds great so far, but there's one big challenge. Mining helium-3 on the moon is one thing. Bringing it back to Earth is a whole different story. So let's look at one possible solution. First, robots or specialized machines would drill into the lunar soil or simply scoop up moon dust to collect the helium-3. Then it gets packed into containers and launched off the moon, heading for Earth. When the containers get close to Earth, a ship called the Space Rapid Transit will pick them up in orbit. Think of it as a reusable space truck with engines that can even use air for thrust. Finally, the ship would land at an airport here on Earth. From there, the helium-3 would head straight to power plants, giving us clean, safe, and almost unlimited energy. See how challenging it sounds, right? Of course, specialists are still figuring out the best way to transport helium-3. But one thing is certain, we're getting closer and closer to building a full mining base on the moon. NASA recently tested a new drill technology called Trident. And as soon as it touched the lunar surface, it started working right away and performed perfectly. For now, its main purpose is to bring soil to the surface so scientists can study it. They want to learn more about how strong the lunar regolith is and how it reacts when drilled. That's definitely an exciting step towards extraterrestrial mining. Because it's not just helium-3, you know. There are a lot of other valuable things that can be taken from the moon. For example, there's water ice on the moon, and from that, we could extract oxygen and hydrogen. Then there could be rare and expensive metals like platinum, rhodium, and iridium. We could even mine iron, silicon, and aluminum, which would be perfect for building things directly in orbit, like future space stations or other infrastructure. Now that we know how important mining the moon could be, you're probably wondering, is any of this even allowed? I mean, who actually owns the moon? The short answer? Nobody. Even though NASA is up there doing research, that doesn't mean the United States owns the moon. Back in 1967, some nations signed the Outer Space Treaty. It basically says no one can claim ownership over our natural satellite or any other celestial body. Not an asteroid, not a planet, not even a random rock floating out there. So, if a country wants to explore the moon, sure, they can do it, but they can't plant a flag and say, "This is ours now." Here's where it gets messy. Companies. There isn't much of an agreement about what private businesses can and can't do out there. For example, a private company sets up a moon base. They land a successful spacecraft, build a small station, and even start digging. The base itself belongs to them, sure, but the land they're sitting on does not. Everyone is on the same page up to that point. The tricky part is, the treaty doesn't really spell out what happens to the materials they dig up. Nobody is totally sure if those resources would even belong to them. And if the materials are not technically the company's, can they even sell them? It's hard to say. So yeah, sorry. Even if you had the cash to build your own lunar base, you probably can't just scoop up helium-3 and bring it back as a souvenir. I mean, unless you want to risk becoming the first person ever banned from the moon. Some places don't look important until the world realizes they hold the keys to the future. That's the case with Canada's Arctic. For most of history, it was just ice, snow, rocks, caribou, and even more ice. But now, it's about to become one of the most important places on Earth, and maybe make Canada a global superpower. Why? Because it's hiding minerals that power electric vehicles, satellites, and missile systems, while the demand is skyrocketing. However, it's not just mining and having resources, it's also about control. Right now, China has a massive head start because it refines over 90% of the world's rare earths. That means if you want to launch a satellite, manufacture advanced electronics, or even just keep the lights on in your fancy smart home, odds are you're relying on China. And that makes a lot of world powers very nervous. Because when everything's going electric, the last thing you need is being dependent on your geopolitical rival. So now, the global clean tech treasure hunt is officially on. The US, Europe, Japan, Australia, they're all competing. However, the latest technology and untapped potential might give Canada the upper hand. Canada's had these minerals for decades. But with low prices, tough terrain, and no global rush, they mostly stayed untouched. However, Ottawa is finally stepping up its game. Back in 2022, Canada rolled out the Critical Minerals Strategy with billions in funding and tax perks to get companies digging. There's also plans to build the necessary roads, ports, and power lines to tap into those remote deposits up north. Canada already produces more than 60 minerals and metals, but 31 of them are now considered critical. 6 of those are having VIP treatment: lithium, graphite, nickel, cobalt, copper, and rare earth elements. But digging it up is just step 1. The real plan? Keep it local. Melt that frozen treasure into shiny new batteries right at home. That means not just mines, but also refineries, processing centers, and high-tech factories popping up where there used to be nothing but snowdrifts and silence. While others are talking, Canada's busy paving roads and stringing power lines. Slowly but surely, they're turning snowfields into a high-tech playground. Getting to all that buried treasure used to be nearly impossible. After all, we're talking about land so remote that roads literally stop hundreds of miles too early. The ground is frozen solid for most of the year. And even if you found something valuable, just getting out was a logistical nightmare. So what changed? Canada has an ace up its sleeve. Don't know about you, but I use it mainly for making memes and music. But geologists? They're scanning the Arctic like it's Minecraft with X-ray vision. Instead of drilling blind, they're using decades-old core samples, plugging them into AI, and getting shockingly accurate predictions about what's underground. It's like upgrading from a pirate's treasure map to a GPS that actually says, "Dig here." Companies like Geologic AI and Cobalt Metals are already doing this, pouring data into AI and getting X marks the spot hits for nickel, cobalt, and rare earths. In the Northwest Territories, Canada is running a pilot lab that uses AI and digital scanning to reanalyze decades-old rock samples. The goal is to spot hidden mineral deposits that old methods might have missed without digging a single new hole. All that sounds great, but maybe I made it sound simpler than it is. Digging up the Arctic is a logistical nightmare. For starters, this isn't just a remote patch of land. The Canadian Arctic is huge. Almost half the country, stretching over Yukon, the Northwest Territories, and Nunavut. We're talking about a region larger than India, with fewer people than a small city. Most of it is permafrost, wilderness, or ice-covered islands scattered across the Arctic archipelago. Temperatures go from barely 50 degrees Fahrenheit during summer to negative 40 degrees Fahrenheit or colder, with ground that stays frozen for most of the year. Fun fact, did you know that negative 40 degrees happens to be the same as negative 40 degrees Celsius? It's the one temperature where both scales intersect. They climb at different rates, but eventually cross paths when it gets cold enough. Just a small trivia nugget for weather nerds like me. Anyways, you can't just roll in a truck and break ground in the Arctic. Up there, roads just stop. Want to build something? It can take years, and one nasty winter can put everything on ice. And if you want to continue up north, you need more of everything. More food, more fuel, more machines, which means even more money. Speaking of money, another chilling fact is how much this all costs. Mining in the far north is way more expensive than doing it in, say, Australia or Chile. An AI might tell you where the minerals are, but people and big machines still have to dig, and that costs a fortune. But that's not all. Most of the Canadian North is Indigenous land. First Nations, Inuit, and Métis communities have lived there for thousands of years, and mineral hotspots often sit right on their ancestral grounds. So when Canada talks about unlocking the Arctic, it's not just a question of roads and robots. It's a question of partnership and collaboration. And that's not optional. Legally, projects on Indigenous land require consultation and, in many cases, consent. The good news, some communities aren't just involved, they're leading the way. In regions like Nunavut and the Northwest Territories, Indigenous-owned corporations and world powers are already shaping how development happens on their terms. If Canada wants to pull this off, it's going to need more than tech and funding. It's going to need trust. So with all that in mind, can Canada pull this off? Honestly? With technological advancements and partnerships, it doesn't seem impossible. But Canada isn't just doing one thing right. It's doing a bunch of things at the same time. Let's recap. Hidden resources? Checked. New strategy? In place. Big funding? Approved. AI tools? Deployed. Indigenous partnerships? Underway. Infrastructure? Already breaking ground. It's a snowball turning into an avalanche. Exploration boosts investment. Investment speeds up roads. Roads unlock more deposits. More deposits attract more factories. It's a feedback loop, and if they keep feeding it, the whole Arctic operation could go from an idea to empire faster than anyone expects, giving a whole new meaning to the phrase frozen assets. But this doesn't just help Canada. It could save the US a whole lot of trouble. If all goes to plan, the US won't need to ship rare earths halfway across the planet. It can just look north, wave at the caribou, and get what it needs from its closest neighbor. That's why the US has publicly backed the effort, offering support and funding to help build a trusted North American supply chain. For Canada, this could be the moment it stops being just a supplier of raw materials and starts becoming a critical power broker in the clean tech economy. For the US, it's like discovering your neighbor has been secretly building a battery factory in their backyard while you were building electric vehicles. And globally? Well, the abundance of resources tends to lower the prices, and that's always a good thing for us regular people. Cheaper cobalt, nickel, and lithium mean cheaper batteries. And cheaper batteries mean more affordable electric vehicles, energy storage, phones, laptops, the works. Now, don't get too excited just yet. Like we said, mining in the Arctic isn't cheap. But in theory, once Canada's clean tech engine is fully up and humming, more supply and shorter supply chains should gradually bring costs down. And it's not just about price tags, it's about stability. Right now, if one country cuts exports or gets caught in politics, everything down the line gets shaky. But with Canada stepping in as a reliable supplier, the global system might get a bit more breathing room. Manufacturers can stop sweating over single points of failure and start building with confidence.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.